All right. Good afternoon, guys. Is
Good
there
afternoon.
any new students today? Offline? Same 17 are there. You're new? Yesterday online. What's your name? You gave your details, right? Yes. From online, is there any new students? Okay. So today we'll learn network components. What is LAN? Local area network. So that is the answer you should never give to an interviewer when they ask what is LAN. Okay? Because they know that is local area network. When I ask you what is VPN, everybody will say virtual private network. So that's the answer you should never give. Okay. So always try to give the definition. Okay. Because the people who are going to ask you what is LAN, he already knows that is local area network. Correct. So your answer should be in the definition. Okay. So that is within a building, multiple devices share resources. Within a building, multiple devices share resource between each other. It's called a LAN network. For example, school library. Then we have CAN. Write it down, I'll explain you. Huh? Overdraft. Oh, okay. Sorry. Yeah, I know. No, it's fine, right? Written? Right on, right. All right. So first one is LAN. So what does a LAN means? So within a building, that means we are all sitting in an NH, right? And we are connected to a Wi-Fi, correct? So within the Wi-Fi, we are all connected. So that is your local area network. Okay, that is one network. Okay, within the network, if we are all connected and if we share resource, that is your local area network. For example, school. So in a school, there will be a Wi-Fi. Under that Wi-Fi in one building, so everybody will be connected. Correct? That is local area network. Likewise, if there is a library separately, in a library you will have a Wi-Fi. So you're getting connected to that Wi-Fi and you're using it. So that is your LAN network. If you come to NH, that is a LAN network. In your home, you have Wi-Fi routers, that is a LAN network. Okay. So within a building, when you when multiple resource share, multiple devices share resource, then that is your LAN network. What is CAN network? It is campus area network. Okay. So within a specific area, that means, say for example, if it's a university, it's not just a building, right? It's a specific area. You have 10 acres, 20 acres of area. So you'll have multiple departments like mechanic, IT, CS, civil, EC, etc., etc. So every building will be separately there. So each building will have a separate Wi-Fi. Correct? Each building will have a separate Wi-Fi and they communicate to each other. Okay. So whatever it is, either physical cable or they're doing the routing, anything it might be. But within a specific area, when you try to communicate between each other, that is your campus area networks. Okay. Mostly in your LAN and CAN networks, you see private IPs. What is this private IP, public IP? We will be discussing it tomorrow in detail. Okay. So where we are using public IP, how our IP is converting into public IP. See, simply you're saying www.google.com or you're searching something. Say, for example, you're searching what is networking. So you're getting the page on your Google, correct? But what is happening in between? So you have an IP address. So your Google address will have an IP address. So you know the Google IP, but does the Google know your IP? No, it will not know your private IP because we don't want to know our private IP to a different servers. If that happens, then in between there will be a hackers, ISPs, governments. So they will come to know, okay, this person is using this IP. So we don't want that. What we are doing, we are translating our private IP to public IP. Okay, so those things will be happening in your backend. So we have a separate translations class after your routing. Okay, there I'll teach you static NAT, dynamic NAT, PAT, everything. So in detail you will learn. So as of now, just imagine, so we are all connected to a private IP. Why we are getting connected to a private IP is because we want to hide our internal identity. I don't want to show my name to outside world. Okay, so LAN and CAN networks are mostly private networks. That is for our purpose we are using. What is MAN network? It is a metropolitan area network. That is within a town or city. Say for example, we are in Bangalore. So in Bangalore, we have multiple police stations. Correct? So each police station are contacting between each other through your RF network. That is a radio frequency satellite. So that is your MAN network. So within a town or city, if you're sharing resource, that is a metropolitan area network. Okay, here public and private, both the IPs are used. Okay, in your MAN network. And what is WAN? That is wide area network. Wide area network. That is completely public. That is within a state or country, when you share resource using a specific service. What is that specific service? Is internet service. We are using Airtel, Geo, correct. So we are using a network and we are getting connected to a different ISP servers. And then you're getting the internet access and you're using the internet. So if you're using a specific service, then that is your wide area network. So what is wide area network is not, it's not up to us. It is ISP sites. Okay. We don't know what's happening there. what sort of public IP is there, how my IP is getting translated, you don't know. You will simply use the internet. So in your Wi-Fi router itself, there will be a translation by default, which is already there. Okay. So your private IP is automatically converted to private IP is automatically converted to public IP. Okay. See, in simple, I'll tell you how this thing works. This is a router, and this is my ISP. This is my ISP. Okay. And here I'm connected to a switch, and I'm having a PC. Okay. So this PC, this network is called LAN network. Why LAN network? This is my network. I'm connected. This is my PC. This is my laptop. This is my phone. Whatever it is. Okay. So this is your ISP. So here we say it as WAN network, because here we are using public IP. Here we are using private IP. Okay. So in this router, this private IP is translated to public, and it will send the packet to this ISP. Again, this ISP will send the packet to this router through public IP. Again, this he will retranslate it to public to private. Okay, these things will happen in backend. I'll capture the packet in your future classes in practicals. I will exactly show you how the IP is changing. You can see it will change from 192.168 to 1.1, and then it will send the packet. Again, he will send it to 1.1. He will retranslate it. That practicals everything clearly I'll show you. Okay, so this is your WAN network using a specific internet service. It's completely public network. Okay, so LAN is like a within a building. CAN means within a specific area, within a town or city, that is your MAN network. And if you're using a specific service which is in country or state level, then that is your WAN network. Okay. All right. Now we'll see this network components. First of all, tell me what is a network? Whatever you know, just tell me.
Sir, I have one doubt there.
Yeah, please.
Sir, this WAN you told, no, that WAN network.
Yes.
So with the WAN network only, it will translate it into the LAN network. What? Like,
No, no, no.
um,
No, no. Don't get confused with these translations as of now, because that is your, say, 15th or 16th class I will teach you. This translations, why I'm telling is it is public to private. So your WAN network will not understand private network.
okay,
Okay.
okay,
That is, he will not know who he is, who you are. Simply he will understand only public IP.
okay,
Okay. Your internet will understand only public IP. He will not know about your private IP.
okay,
All right.
okay.
Okay.
Continue.
No worries. What is a network? Tell me, guys. Whatever you know. One or more devices connected to each other. Very good. Next. Anyone else from online? Offline? Huh? Exchange of data. Okay. Communication between multiple devices. Okay. It is the, in simple, what is a network means? Are you able to hear me? Devidas, I can't hear you. What is a network? It is the interconnection. Interconnection between two or more nodes. More nodes. It is an interconnection between two or more nodes. That means if I have a router and I have another router and I have another router, then this become a network. This is one network. This is another network. We have two networks here. If I connect with only two routers, then this is one network. Okay, if I have a switch connected with router, again, this is one network, because I'm going to give an IP on the interface. So this will become one network. Okay. So likewise, it is an interconnection between two or more nodes. Okay. So why we require, see, before going to this, what is networking and all, when this networking starts, who started this networking? Why we require networking? For communication, yeah, obviously for communication. But when this started,
When the war is going on USA and Vietnam.
correct, not Vietnam. So Vietnam is late. It was started in your Second World War. In 1945, they started this networking concept. Why? And who started? The Americans. Because they were sharing resource as physically. That means if I have to send some data, I have to call a person. He has to carry a book or something, a secret page, and he has to send it to that person. And he will be reading it. So this is how it has been done all the years earlier. Correct? But this then later they came with networking. Until then, they were only sending data through physically. To overcome that, Americans brought this TCP/IP concept in your 1945 itself. Okay, so they came to know, okay, let me share the resource through computers, through a network. So I'll create a protocol. In that protocol, I'm going to type whatever my information is and I'm going to send it to that person. So there in your 1945 only the networking started. So reason being, it is more secure. When I send the data, see, when I send a person, then there might be a high chance that anything might happen in between. So that they send it through this network so that the data is more secure, it is cost efficient, time is saved, and it's more fast. Within 5-10 minutes, the data is reached to one country to other country. Correct. So these are all the advantages that we had in your networking. So that is the reason we use networking, and it is data integrity is there. What is integrity? Hello. Secure. Okay. Correct. That means, see, if I'm writing something on the paper, I'm writing tomorrow your class will start by 2 p.m. and I'm giving to you, to the person who is sitting at the last. What if he changes the name to instead of 2, if he changes to 4? That is not correct, right? So I have to make sure that this person doesn't do it. That is integrity. He has to reach whatever I written that the class starts by 2 p.m. Understood? So that is your data integrity. That means in between the modification should not happen. So a modification cannot be happen in your network. A modification can be happened if I write a paper. If I'm writing in a paper and I'm asking him to go give it in silkboard. So meanwhile, in the between, he can change the paper and he can write whatever he wants and he can give it, right? That he can do. But if I send the data in the network, he can change it, but I will come to know it that he has changed. How I will come to know? So there are multiple ways of it that we will learn in future. Okay. I can come to know this person has changed the packet. I can retransmit the packet saying this is not the packet you send it to me. Send me the original packet. Likewise, I can do it. So data integrity is there. Okay. And reliability is there. If I'm sending from one device to other device, and if data for some reason the device went down, I can still send it from different device. Correct? I can still send it from different device. That is your reliability. So all these are the reasons we had this networking. Okay. And it is more secure, more reliable, data integrity is there, time efficient, cost efficient, security. So these many advantages are there. That is why we are using networking. Okay. All right. What is a topology? What is topology?
Is an
Topology. What is topology?
design of network.
Hmm?
Design of network.
Design of network. Very good. You can say it is a graphical representation of network. It is a graphical representation of network. That means it displays how the nodes are connected. How the nodes are connected in a network. See, when you go to your whatever Google, ChatGPT, whatever it is, you will get multiple definitions. but I'll always give a definition to any concept. I'll give you in a very small line. One line, I'll give you a definition. So that will make you understand more clearly. Okay. And then go to your Google or whatever it is. Straight away, if you go to Google or your chat GPT, sometimes you get confused. So every time your answer should be simple, yet you should understand it clearly. That makes sense. Because how many concepts you are going to learn in CCNA, I'll tell you in a second. So now we are learning what is network, network components, IP address, subnetting, OSI layer, TCP, UDP, okay, ICMP, ARP, Telnet, SSH, routing, you will learn static, default, RIP version 1, version 2, EIGRP, OSPF. In switching, you will learn DTP, VTP, STP, Ether channel, port security, DHCP, and then HSRRP, VRRP, access point, trunk point, trunking, TFTP, SNMP, FTP. So many. Still, I'm leaving something. Still, you learn 10 more concepts. So you can't keep remembering each and every definition like a proper definition. Okay, that you can't do it. Even for a trainer, it is not possible. So always try to take a small keywords that make sense. Okay. So what is a topology? Graphical representation of network. So I'm telling two routers and three switches and six PCs are connected. How they are connected? How they are connected? Is router and router connected, or a router and PC is connected, or router and switch and then PC is connected? You don't know, right? So that is topology. How your devices are connected in the network, that is topology. Okay. See, when you go to lab on third floor, you can see multiple devices. How many of you went to lab and saw? Yeah. Did you see the devices, physical devices? Yes. How the devices are there? One, two, three, four. And then again one, two, three, four. Correct. So eight devices are connected like this. But which device is connected to which device? Do you know? No. How do you know? You don't know. So for that, you need a topology. Okay, this is how we can see in the pillar, there might be a A4 sheet sticking. So there you can see the topology. This is how it is connected. Okay, every devices are interconnected to each other and they're all connected to a terminal server. So next week I'll take you to the lab and I'll show you. Okay. So how they are connected between each other, that is your topology. So for example, here I'm saying I have two routers, two switch, and I'm saying four PCs. They're all connected. So how they are connected? The graphical representation is like this. Two router. So under router, switch is connected. Okay. And then four PCs. Here I have two PCs. And again, here I have two PC. So this is the topology. How they are interconnected between each other, that is your topology. Okay. All right. Written this topology. What is topology? Yeah. So we have multiple topologies. Bus, star, hybrid, tree, okay, mesh. So these kind of topologies is there. But right now we are using only mesh and star. Okay. So we will discuss these two. Okay. So this is my PC1, PC2, PC3, PC4, and PC5. Okay. So PC1 is connected to PC2, 3, 4, 5. And 2 is connected to 3, 4 and 5. Likewise, 3 is connected to 4 and 5. And 4 is again connected to 5. Okay. That means what is mesh topology means? Each and every device is connected between other devices which are in the network. Every device is connected to all other devices in the network. See, this PC1 is connected to PC2, 3, 4, and 5. Correct. Likewise, 2 is connected to 3, 4, and 1. Okay. What is the advantage of this one is, see, for example, I'm telling you, this link has gone down. This link between PC1 and 2, this link has gone down for some reason. Might be a technical error or a physical error, whatever it can be. Okay, this link gone down. Can I send data to PC1 to PC2 now? Why? I can send the data. Exactly. I can send it to PC5 and this way I can send. Correct. I can send it to PC4 and I can send PC3 and again I can send. Correct. So even though if a link goes down, I'll still have the connectivity to reach the PC2. Okay, but what is the disadvantage? It is very complex. It is very complex. That means, for example, I'm going to add another device in the network. Then how many cables I need? Another 5 more cables. 5 devices are there. So I have to connect with all 5 devices. So I need 5 more cables. If I add one more, then again 6 more cables. So it will become very complex. In your enterprise level, there will be like thousands of devices. So that is not possible for us to connect in such a way. It is complex, very cost, right? Cost effective is more. Implementation cost. Number of cables are high. Number of cables are high. Correct. So these are the disadvantages in your mesh topology. But what is the advantage? Even though a device goes down, still the connectivity is there. Correct. So where we are using this kind of topology means in your internet side. We are not using in your enterprise level. Internet side, they are using it because we can't afford the internet goes down. Correct. Even when you type google.com, if it takes 5 seconds, we don't have patience. Correct. We want it immediately. Suddenly, what we are doing? We are going to flight mode. Turn on again. I can't wait for 5 seconds. I need more fast. Correct. So imagine if a network is gone, like internet service is gone down. Can we afford that in real time scenario now? No way. So there they will have multiple redundancy paths. Redundancy means backup path. So they will have multiple backup paths. Okay. So in your internet side, they are using this mesh topology. Okay. And another one is star. What is star? So in your star device, we have this kind of central device. We have a central device. That means every device in the network are connected to that one particular central device. So this, so PC1, 2, 3, 4, and 5. So this PC1, right? He will behave like a central device. Okay. And if PC2 has to send information to PC5, he will go via PC1. And PC4 has to send anything to PC3, he will go via PC1 only. So here the advantages are means more simple, cost effective, and less number of cables. Whatever disadvantages we have in mesh topology, that will become the advantage of your star topology. Simple. And what is the disadvantage? If a link goes down, then no communication. Then no communication. No communication will be there between the devices. That means this PC1 goes down and all these 4 devices are up, but still no use, they can't send the data to other devices. Okay. But see, in your real time, we are not depending upon the one device. No way. Okay, so you will have multiple devices connected. If this device goes down, immediately within 3 seconds, the other device will come up. I'll show you in practicals, and I'll show you the campus architecture of how the devices are connected in a real time. Okay. AC remote. Oh, reduce the temperature. 21 or something. No, you're increasing it. Reduce it. Yeah. So you will have multiple devices. I'll show you how the topology they are designed in your three-tier offices, two-tier offices, like a small startup office, how they will configure, how they will have the devices. I'll show you. Okay. So as of now, this is your star topology. Okay. Any doubt on in mesh topology and star topology? And star topology where they're using? In your enterprise level. So nowadays they prefer this star topology. So if I have, say for example, if I have like 20 devices, all the 20 devices are connected to a switch, and that switch, one switch is connected to a router. Okay, so this is how it is being connected. Or a router, we connected to Wi-Fi, and within the Wi-Fi, we are connecting multiple devices. Okay. Now come to your presentation. So what is a topology? Topology defines the structure of how all the components are interconnected to each other in a network. Here they said components, but it is the devices or nodes. Okay, hops. There are multiple names. We say hop, nodes, devices, end devices, edge devices, all means whatever you're connected from your side. Okay. And type of topology we are going to learn mesh and star. Now come to mesh topology. So what is mesh topology? A mesh topology is a network setup where each computer and network device is interconnected with one another. Okay, this topology setup allows for most transmission to be distributed even if one of the connection goes down. See here you can see clearly. That means every device is connected to each other and one link goes down, still the communication is possible because we have multiple redundant links. You can communicate to that particular device through another device. That is a mesh topology. And disadvantages we have seen. See, look how complex it is. Correct. So it is not possible for a network admin to configure these kind of topologies. Here we are having only six PCs, but your TCS will have hundreds and hundreds of topology, correct devices. That is not possible. Okay. Star topology. So star topology is one of the most common network setups. In this configuration, every node is connected to a central device like a hub, switch, or computer. So the central device, network device acts as a server and the other devices acts as a clients. So it is like a server client model. So everyone will go through the server. Okay. And advantages is what? More simple, easy to configure, cost effective. Correct. So these are the advantage and disadvantage. If central device goes down, entire connection is gone. Okay. But in real time, it will not happen because we have two central devices. The data will be going through one device. If that device goes down, immediately the other device will come up. Okay. So it will not be a problem. There we are having multiple switches and routers. Even routers, we are having multiple routers. So if one router goes down, the other router immediately will come up. Okay. All right. See, this PPTs and all, I'll upload it in the recordings and documents and I'll share you the drive access. I don't think so I can do it today because the verification is not over yet. By tomorrow after your class, 100% you will get it. Okay, I'll make sure everybody got the drive access and you tell me in the class only and then you can leave. Okay. See, unicasting. Yesterday we have seen this unicast broadcast, right? What is unicast? One to one communication. That means only one person is sending. And multicast means one group. To one group he is sending, not to every students. So broadcasting means one to all. I send information to everyone, and any casting means one to the nearest one. Okay. You can see the color difference. See here, multiple colors are there, but here every color are same, but receiver has the different color. That means I'm specifically sending to this person. Okay. And then broadcast domain, collision domain, I'll come later. And you have this half duplex and full duplex. Yesterday we have seen this. So half duplex means one two-way communication, but only one people can send data at a time. See, that's why you can see direction of data one at a time, direction of data another at a time. But full duplex means both the two-way communication. That means a data can be sent and received at the same time. Okay. And see, OSI layer will learn in detail each and every layer. But here, a small intro I'll give you. So OSI layer is a 7 layers. We have 7 layers in your OSI. Okay. So the top 3 layers are called as software layers. That is your application layer, presentation layer, and session layer. Okay, these layer are called as software layers. And physical layer, data link layer, network layer are called hardware layers. Why it is called hardware layers means, see, in your physical layer, what do you have? Cables, PCs, correct? You have laptops. Those devices works on your physical layer. And in data link layer, you will have switches. Okay, you have L2, L3 switches works on your data link layer. And then you have network layer. Here you have routers, servers, firewalls. These all work on your network layer. Okay, these are all what? A physical devices. See, underneath you can see last one, that is a SD-WAN server. Okay, that is a SD-WAN server. And you can see multiple routers there. Multiple switches are there. That is a switch. Those are routers. So these are all physical devices. So that's why we say, and these physical devices works on your individual particular layers. So that's why we call them as hardware layers. Okay, whereas your application presentation session layer, they don't work on devices. They are completely logical. Okay, we are using that for troubleshooting purpose. So that's why they are called as software layers. Okay, each and every layer I will explain you in detail. Don't worry. From application layer to physical layer, our data comes from application to physical. Again, how the data goes through physical to application. Okay, I most probably this Friday I'll take a class or Monday. Okay, we will learn this OSL layer. And here you can see something called transport layer, and it is called as heart of OSI. Why? Because this layer is responsible for sending the data from application to physical. Okay, for end-to-end communication, this transport layer is important. That's why we call it as heart of OSI. Okay, your TCP UDP works in this layer, and your TCP IP protocol works on your transport layer, and this is responsible for sending the data from source to destination. Who? Your TCP IP. Okay, so that's why we call it as heart of OSI. All right. Types of addresses. So we have IP address, that is called as logical addresses. It can't be permanent for you. So that's why we say it as logical address. Okay. And IPv4 is a 32-bit. IPv6 is a 128-bit. So how many bit is your IPv4? 32. That means 2 to the power of 32 addresses you can get from IPv4. That is almost 4.2 billion addresses. 4.2 billion IP addresses. Okay. And IPv6 is 2 to the power of 128. Somewhere they believe this will never get exhausted. Which one? Your IPv6. That many addresses you have. Okay, you can't even count it. Wait, let me show you. See here. These many addresses you have in IPv4 top. and see how many addresses you can get from IPv6. You can't even count. That many addresses are there. Okay. And in your IPv6, there is no concept called translations. In your IP4, that's a very, very important topic, your translations. Because without translation, you can't get internet access in your IPv4. Whereas in IPv6, there is no concept called translation because they believe if you can give public IP to each and every individual. Okay. And once your ISP is completely shift to IPv6, then you will get IPv6 addresses. Okay. With the translations, we are still working on IPv4. Okay. See how many addresses? Like you can't even count, right? That many are there in your IPv6. Okay. So this IP addresses class is tomorrow. Okay. Again, I'm telling you, tomorrow's class is very important. If you miss tomorrow's class, Thursday's class and Friday's class, you will not understand anything. Okay. Online or offline, try to attend it. Don't miss tomorrow's class. Very important. Okay. Those who have no knowledge about like networking, IP addresses, how it is range is done. If you don't know about that, then tomorrow's class is very important. That's why. Because after knowing tomorrow's class only, the Thursday's class, we are going to divide the networks. To divide the networks, the basics should be very sound. Okay. All right. Now, so we'll keep this tomorrow. Simply, you can understand IPv4 is 32-bit. IPv6 is 128-bit. And MAC address is a physical address that you have it in your laptop. That is your 48-bit. Okay. Here you can see hub. What is a hub? You know any idea about hub? Huh? Centralized device. Yes. It accesses server. Okay.
Non-intelligent device.
Non-intelligent device. Here it is. Dumb device. You said non-intelligent device. Very clever. Very intelligent you are. See, we don't use hub anymore. Hub is completely replaced. Hub is completely replaced by switch. Now we don't use hub at all. Initially we were using hub. Why we are not using hub? I'll explain you. See, it works on layer 1. It works on layer 1. That means which layer? Physical layer. Layer 2 is data link layer. Okay, and layer 3 is network layer. Okay. It works on layer 1. Okay, they say this as a dumb device. Why dumb device? I'll tell you. And it has single broadcast domain and it has single collision domain. This broadcast domain, leave it as of now. While I explain the router, you will understand clearly. What is this collision domain and what is this half duplex? Now I'll show you. See, when devices are connected like this, multiple devices, say for this hub, this is a hub and multiple devices are connected. Okay, like this it is connected. So, guys, what is collision? Forget net, like I don't want like a technical answer. Just simply say what is collision. What is a collision? Collapse. Accident. Correct. Collision means collapse. Very good. It's like an accident. When two things meet at the same intersection point, then your collision will happen. Correct. It might be a car in your road traffic, or if two doors meet at same point, that is a collision. Correct. So what does this collision domain means? See, here I have PC1, PC2, 3 and 4. Okay. So he will be sending the information to PC2. So the PC4 is sending to PC2 or PC1, PC3, anyone for matter. He can send it like this, right? Correct. But here there is a hub in between. So what this hub does is he will not send it just to PC2. He will send it to PC4 and to PC3 also. He will send it to each and every devices that are connected within the hub. All the devices that are connected with the hub, he will send that information. That is a one problem. The other important problem is, so he is sending information and he is also sending here. here. So meanwhile, PC3 wanted to send to PC2, PC1. What he will do? He will send the information here. Correct. So he will send it here so that he will again send it to PC4, PC2, PC1. Because hub is not going to filter anyone. He will send whoever it is connected, he will just keep sending the information. Who? Your hub. Okay, that means he has a single collision domain. That means whatever information comes to a hub, okay, I'm telling, okay, send it to PC2, but still he will send it to PC1, 2, and 3 also from PC4. It will send the information to all the devices which are connected to hub. Very important point. Okay. Because in your interview, they will ask you difference between hub and switch. In your mock interviews, be prepared for that. It's like a basic questions. They need to understand, do you know the difference or not? See, simply you can say, okay, hub is a central device, switch is also physical central device. Hub is act like a server, so does the switch. Okay, hub is replaced by switch. It works on layer 1, it works on layer 2. It is a dumb device, intelligent device. These are not the answers. You have to give technically. See, one device is completely replaced another device. Then you have to technically say, this is the important reason that it has been replaced. Okay, you have to explain what is a collision domain, why switch is more secure, why not hub. Answer should be technical. Okay. So when PC3 is sending, PC3 wants to send to PC1. PC3 wants to send to PC1. PC4 wants to send to PC2. Okay. So what will happen? He will also send. He will also send. And he is going to distribute to each and every person. So at that time, collision will happen because it is half duplex and as single collision domain. Single collision domain. Okay, so this is the reason a collision will happen between devices and then the hub will go down. Your interconnection will go down. So that is why we are not using hub anymore. Okay, and if you cut down, you have a switch. See, switch works on which layer? Data link layer, layer 2. There it will read the MAC address. Switch can read the MAC address. So that is why we say it as an intelligent device. Whereas your hub will not learn any addresses. Because why? Even though when I say PC2, it is sending to each and every one. What's the point? Correct. See, your switch also will do. First time I'm telling, okay, pass the information to, what's your name? Mohammed. Okay, pass the information to Mohammed. First, initially I'm coming to class. Do I know who's Mohammed? No. Right? So I'll ask who's Mohammed. He'll say I'm Mohammed. So next time I'm not going to ask who's Mohammed. I'll directly call Mohammed and I'll give it. So that's what your switch will do. But whereas what your hub will do, he'll come and ask who's Mohammed. He'll say he's Mohammed. He'll give the information to Mohammed. Again, next day he'll come. Again, he'll ask who's Mohammed. Okay, he can't identify you because he doesn't read anything. Who? Your hub. Whereas switch will read the MAC address and he will store it in the MAC table so that he will know exactly this is the person. He is the person. Likewise. Okay. And it has per port collision domain. It has per port collision domain. Okay, that means, so here I have PC4, 2, 1, and 3. Okay. So here a switch is connected. All right. So if I want to send information to PC2, so there is like a separate channel. If you want to send the information, you will send it like this. Likewise, you can imagine. And this switch will send only to PC2. Okay. And meanwhile, PC3 wants to send to PC1. He will send it via this channel and he will receive it. If PC2 has to send to PC1, the same time, he will use a different channel like this. Okay. Like you can say like a two-way road. So one way in your highway, one way it is going, the other way it is like other way. Correct. Whereas if you take like for HSR like this, normal road. So in one road only, both the things are happening, like going also, coming also. Right? So that's what your switch do. It has two channels. So data will be sent and received at the different channels so that the collision will not happen. Okay, and it is a full duplex. It is a full duplex. So this is the difference between per port collision domain and single collision domain. Per port means he will send it to only that intended person, whereas your hub will send it to all the connected devices. Hub will send it to all the connected device. That's why it is single collision domain. Any doubt on your per port collision domain and single collision domain? Understood? Online?
Sir, I have a doubt. I'm not sure if this is the right time to ask this, but uh, like when multiple devices use multiple nodes, multiple devices use the switch,
Okay.
and does the it also affect the speed? Like you said, there are multiple channels, so that means uh, if more devices are connected, does that affect the speed of the data as well?
No, it depends. See, if there are multiple devices connected, it doesn't affect the speed of the switch. But what will happen if all the devices are sending data at the same time and the data is like more?
Mm-hmm.
Then it will have a bandwidth problem and overhead problem. So that's why we have a link. So we have a Ethernet link, we have a fast Ethernet link, we have a gigabyte Ethernet link, we have 10 gigabyte Ethernet link. So each link will have a different speed.
Oh, okay.
Okay, each link can carry this much data. So according to that, a data will be sent. See,
Thank
at
you.
that time, if everybody is sending data, then obviously it will impact your speed of your network. Okay, that will happen. So
Okay, sir.
that's why in your enterprise level, they will have multiple switches. So it will share the load. Okay, see, I will take a class in your future in your switching. So for example, if two switches are connected like this, okay, and who asked me this question?
Prashant.
Yeah, okay, Prashant, if two switches are connected like this, okay, you think they will be connected like this? No way.
Oh,
They'll be connected with multiple links like this. Up to 8 you can be connected. Up to
okay.
8 links are connected like this. Okay, and all the 8 link we will make it as one link, and all the 8 link will share the resource.
Oh, okay. Okay.
Okay, the data will be split into each and every link and we can send the data. We are not depending upon one link or two link. Up to 8 links can be active at the same time. And all the 8 link will act as a one link so that the data will be distributed evenly and send the data.
Oh,
Okay, so this I will show you in your switching class.
okay, sir. Thank you.
All right. Any other doubt regarding your collision domain? No. Now come to your PPT. What do you want? Per port collision domain. Okay, here from 4 to 1, 3. Okay. So here what will happen? If he wants to send data to 2, he can directly send only to 2. For the first time, what the switch will do, he will send it to 1, 2, and 3 also. Because why? He don't know who is Mohammed. Correct. He don't know who is PC2. After sending each and every one, he will ask, are you PC2? He will say, no, I am not. Correct. And 3 will say, I am not. And 2 will say, okay, I am PC2. And he will reply like this. Okay, so when the reply comes like this switch in between, he will read the MAC address of this PC2 and he will store it in the MAC table. He will store it in the MAC table. So next time when I send the information to PC2, he will directly send it to PC2. He is not going to send to 1 and 3. That is your per port collision domain. Okay, first time he is going to send to everyone, but next time that is a broadcast. First time he will send to everyone because I'll come and ask who is that person. Am I asking only to these people? No, right? I'm asking to everyone. So that is a broadcast. After that, it will be a unicast. He will send directly to PC2, one-to-one communication. So now this PC4 has to send to PC2. Now again, if PC3 is sending to PC2, this time what he will do? He will directly send to PC2 because already the MAC address is in the switch. While he send the device to information to PC4, he store the MAC address of PC2 in the switch. So when the PC3 wants to communicate to PC2, he will directly send it to PC2. So that's why we call it as an intelligent device, and it reads MAC address, and we say it as per port collision domain. Understood now? And at a time you can send and receive data also because it is full duplex. At a time you can send. That means PC1 can send to PC3 and PC2 can send to PC4 also at the same time. All right. Online guys, any doubt?
No.
All right. Good. See, I know this is your first class. If you feel like I'm going too fast, you can stop me. If I'm going very slow also, you can stop me. If you didn't understand, you can ask me. That is not at all a problem. Okay. I want to make sure that you understand the topic and then we'll go to the next topic. Okay. Because each and every topic is very important in your CCNA. Okay. So don't hesitate. If you have any doubt, you can ask me. All right. That's not a problem at all. And see, I'm planning for 20 classes of your CCNA, 20 classes. But if I want, I can take 25 also. If I want, I can take 23 also, 22 also. That's not a problem at all. It's up to me and you guys. You have to say, okay, let's learn today this much topic only, sir. I feel like this is too much. Okay, then we'll stop there only. And I'm not going to take complete 2 hours class also. I'll keep it to 1 hour 40 minutes. My every class is 1 hour 40 minutes on every batches. I don't push to 2 hours. And when I schedule my syllabus, I know exactly how to schedule. That means I'm not going to take the OSI layer completely on one day. I will not do that. I will break the layers. So 3 layers will learn one day, 4 layers will learn another day. Okay. If you come to routing, so one class I will take static and default, the other class RIP version EIGRP, another class OSPF. Okay. So I'll already have a schedule. That is according to students' potential only, I've made it like that. But still, if you feel, sir, it is too much, I was not able to say Tamil, I have problem. Like, can you teach me again? Not at all a problem. Okay. So make sure you learn it completely. Okay. All right. So this is a layer 1 device and it is a dumb device. Why we are saying it as a dumb device is because it doesn't learn anything. Okay. Cut down, come to switch. It is a layer 2 device and it is an intelligent device because it learns something, that is your MAC address. It works on data link layer and it learns something. Understood? Here you can see it has per port collision domain. And here it has single collision domain. That is the reason hub is sending the data to everyone and switch will send to only PC2. Okay. And it is full duplex and this is half duplex. So now a interviewer asks what is the difference between hub and switch? How are you going to answer? So you can say hub works on layer 1. This is layer 2. It is a dumb device because it doesn't learn anything. Now you can add a point. Correct. And switch is an intelligent device because it learns MAC address. Okay. And it has per port collision domain, your switch. Hub has single collision domain. That means, so there might be a high chance of collision in your hub. Whereas in switch, it will not happen because it has per port collision domain. So at the same time, he can send and receive data also. And he is not going to forward to each and every devices. So this much information makes sense. Okay, and switch has multiple secure, it is more secured. We have VLANs, we can configure that this. You can leave those things. As of now, this much point is better. Okay, so most probably they are asking this difference between hub and switch. Reason being, to initially they will not dive deep into your, what do you say, questions. So straight away they will not ask, tell me TCP flags. No. First they will start, did you do CCNA or not? Yes, I did CCNA. Okay, tell me a difference between hub and switch. Then they will ask, what is the difference between TCP, UDP? Then you will say, this is secure, this is unsecure, reliable, retransmits, blah, blah, blah. So many points are there. You will tell all those things. Then they will ask, why? Then you say, this will go through handshake, this will not. Okay, what is that handshake? It is going to send the packets of synchronized packet and acknowledgement packet, whereas it doesn't happen in UDP. Then they will ask you what is the packet in the three-way handshake. Then you have to say synchronized packet, acknowledgement packet, and syn acknowledged packet. So these packets are used in TCP. So they'll ask what does exactly in the packet, in the flag, it is being transmitted. So you say sequence number and acknowledgement number. So this is how they will dig you in your interview. One answer you will give you, they'll ask other layer. One answer you'll give, next question, next question. So this is how the interview will be in. Okay. Right now only start preparing according to your interviews. Best time is your CCNA, because in your CCNA only you are having only one class, that is a 2-hour class. The rest 22 hours you have. Correct. So you can prepare very nicely. Once you start routing switching, you will not have much time. Okay. So every day go through the recordings. In class, you will feel like, okay, I understood everything clearly. Of course you will. But once you go home after 2 days, you will feel like, oh, what is this concept? Okay. So start preparing from the day one only. So imagine this is your day one. Okay. Here itself, you start preparing according to your interviews. Okay. So hub and switch you have seen. Now come to your router. So router, here you can see it is a layer 3 device. That means which layer it is working on?
Yes.
Network layer. That means it is working on network layer. Correct. And it is a intelligent device. Why we say router is an intelligent device? Correct. Because it learns IP address. It learns the IP address. So that's why we say it as intelligent device. And again, your router is a full duplex. Correct. And router, it has per port collision domain, just like your switch. But one thing you can see here, difference is here it is per port broadcast domain. Whereas in your switch, it is a single broadcast domain. So now we will learn what is this broadcast domain and per port and single broadcast domain. Okay. Okay. So what is this per port broadcast domain and collision domain means? See, there is a packet coming in. Okay. And it is saying send it to switch 5. Okay. Is there any switch 5? But when the packet comes to switch 1, he will send it to switch 2, switch 3, and switch 4 also. Okay. He is going to broadcast to everyone, one to all. But is there any switch 5? No. He will drop it. He will drop it and he will also drop it. But still the packet, he will send it. Who? Your switch. That is your single broadcast domain. Okay. Whereas in your router 1, if a packet comes in, send it to R5. Is there any R5? No. He'll simply drop the packet. He is not going to forward to each and everyone. He will not do the broadcast. If a packet comes in, send it to R3. He will exactly send to R3 only. He's not going to send to R2 or R4. Okay, if a packet comes in, say R1, say R2, he'll send it to R2. R4, he'll send it to R4 only. He's not going to send to each and everyone, even if it's the first time. If a packet comes in with a different name, he will simply drop it. He's not going to forward it. That is the difference between per port broadcast domain and single broadcast domain. Okay. Switch has a single broadcast domain. That's why he's forwarding to each and everyone for the first time. After knowing, okay, this is the switch 3 address, then per port collision domain comes in. He will directly send it to only switch 3. Correct. But for the first time, broadcast will happen in your switch. Whereas your router, he will not do it. That is the per port broadcast domain. Okay.
How router 5% or not?
R5 present or not? Because he will have the routing table. Okay, your router will have a routing table. Okay, these are the devices connected from me to others. Okay, I exactly know you are my students. Okay, if a new student comes and sits, I'll directly ask him, who are you? Once after getting the verification, and then only I'll make him to sit. Like I'll get to know about each and everyone initially. That is your router. So router will have the routing table, who are the devices connected directly, who are the devices which are connected. See, router 1 is here, router 3 is here. Imagine if there's a router there here also. Here there is another router, that is your R6. Here there is another router R7. This router will know who's R7 also. How? Because whatever network here it is connected, that network will be in your router 1 also. Okay, this you will learn in your routing. Okay, so he is not going to forward just simply like that. If someone is there, you will send it. Otherwise, you will drop it. Okay. Any doubt online, guys?
No, sir, cleared.
Clear. What about others? Only one person has answered.
No, sir, no doubt.
No doubt.
No, sir.
No.
Not doubt that.
No doubt. Very good. Okay. All right. Write down this router switch and all. What is your name? Last. Piyush. Vishal. Vishal, are you able to understand? You're able to understand everything? If you have any doubt, come to me. Okay. What about you guys? You too. Understood? Per port collision domain. Okay. PC4 wants to send data to PC2. Okay. Here there is a switch in between. So initially what he will do, he'll send it here and switch for the first time. He is going to send to everyone. This one, I'm telling this is a switch. It's not a router. It's a switch here. Okay. So switch is connected here. Switch will send to each and everyone. Okay. Because he doesn't know who's PC2. So he's going to do the broadcast for the first time. And next, what will happen? This PC2 will say, I'm the PC2. Here also packet will go. Okay. What's your name? Dinesh. He'll ask, who's Dinesh? Is he Dinesh? No. This PC, I've changed the name to Dinesh. Okay. Here, this is Arun. Here, someone else, ABC. He will say, my name is Arun, not Dinesh. He will drop the packet. Here, name is ABC. He will drop the packet. So only Dinesh is going to send it back. So he will send it back here. Okay. So this switch, what he will do? He will learn the name Dinesh. In his switch, he is going to write down Dinesh. Okay. He will write it down in his MAC table. And then the packet will go to PC4. So next time, PC4 is sending to PC2. That is to Dinesh. He will say, send it to Dinesh. Now the packet will come to the switch. This time he exactly know this is Dinesh. He is ABC and he is Arun. He know he is Dinesh. So he'll directly send it to Dinesh. He's not going to broadcast it. That is per port. Understood? Written this. Okay. And we are having types of cable. So first one is straight through cable and crossover cable. So if it's a different device, then we are using uh, straight through cable. If it's the same device, then we are using crossover cable. Here you can see straight through cables are needed to connect a switch port to a router or a host. It is used to connect different types of devices. This is your standard Ethernet patch cable. That is your straight through cable. And crossover cables are used to connect similar type of devices. If it's between switch to switch, we are using crossover. If it's router to router, crossover. PC to PC, crossover. Okay. And if it's the same different PC to switch, then we can use straight through cable. And we are the serial cable. Now we are not using the serial cables. This is very slow and it transforms only less data. So we are not using any serial cables. Okay. So this is used to connect two routers. In the serial interface, we have a serial interface. Through that serial interface, we are using this cable. Okay. So what is this console cable? See, you're buying a new device. You bought a new router. So in that router, everything will be new. No configurations, nothing. Everything is new. So at that time, what you will do, you will take a console cable, you will connect it to a router to your PC. So initial configuration you will be doing in your PC, right? You will connect a router and PC and you will do, right? So that is what? Through your console cable. So through console cable only you will get the access of from your laptop, and then you will be able to configure things. Okay. See, this is fiber optic cable, but initially we had this copper cable. Okay, right. See, learn for read the definition. So fiber optic cables transmit large amounts of data at very high speed. This technology is therefore widely used in internet cables as compared to traditional copper wires. So fiber optic cables are less bulky, lighter, more flexible, and carry more data. So initially we had copper cables. Okay, so that is heavy. It carries less data and it is not flexible in real time. So that's why we are completely now shifting to fiber optic cables. Your copper cables transmit electrical signals. So data will be transferred through electrical signals, whereas your fiber optic cable transforms light signals. What is the speed of light? 3 into 10 to the power of 8. Don't worry, they will not ask these questions in interview. Okay. So it is 3 into 10 to the power of 8. That much speed it will send the data. Who? Your fiber optic cable. Whereas your copper cable will transform through electrical signals. So that's why nowadays in your enterprise level, in internet side, we are only preferring fiber optic cables. Okay. Okay, I have a task for you. So in this diagram, tell me how much collision domain and how much broadcast domain. I'll give you 5 minutes. Broadcast domain. Excuse me. How many broadcast domain? How many collision domain? Tell me. Tell me. Anyone?
So first one is the hub is connected to three devices, no? That is in broadcast domain and as well as collision domain.
No. Hub is a single broadcast domain only.
Okay. Okay.
Just tell me an answer. How many collision domain? You. Random answer. Okay, forget collision. Tell me how many broadcast domains? Two broadcast. Any other answers? Each switch will have one broadcast domain, correct? Okay. See, I'm not going to judge you. Just tell me how many. If I get more wrong answers, then it is easy for me to explain you. Okay. Okay. What about this side? I need some answers. You tell me. Dinesh. And you also. How many broadcast? Huh? Two. You. Three. Four. Two, three, four. You. Five. Three. Okay. See, this is what an interview question is. Okay, they will give you a topology and they will ask you how many collision domain and how much broadcast domain. If you're able to answer that, then they will understand you know what is collision domain and what is broadcast domain. So there's two ways of asking. Either they might ask you what is the difference between broadcast domain and collision domain, or they might ask you what is difference between hub and switch. They can ask you what is the difference between switch and router. These are the questions they can ask you, and you will explain it. That is one way. Or simply they will give you a diagram like this, and they will ask you how many broadcast domains and collision domains. So this is another way. At most, you can expect these kind of scenario questions only. Okay. So how many broadcast domain means? See, your router has per port broadcast domain. That means what? So this is one broadcast and this is another broadcast, and it is connected to switch only. So this switch is completely one only. This also completely one only. So only two broadcast domains. Because this switch is connected to this broadcast domain only, right? So that's why two broadcast domains. Okay, here you can see two switches are connected. It doesn't mean that this is single broadcast domain, this is single broadcast domain. No, they're interconnected between each other. Correct. If there is a router in between, then that is a different scenario, two broadcast domain. But here they are directly connected. So everything which are connected here will be taken as one. Okay. So broadcast domain is BD. Broadcast domain is 2. Collision domain. How many collision domain? Give me an answer. 8. 8. 8. 8. Tell an answer. It's okay. Dinesh. 4. 4. 4. See. This is a switch. Switch has how many broadcast domain? Per port. Every port is a broadcast domain. See, if I am having a router, it's a per port broadcast domain, correct? So, if I'm connected like this, then this port is one broadcast, this port is another broadcast, another broadcast, another broadcast. So, 4 broadcast domain. Likewise, collision switches per port collision domain is switches. So, this port is 1, correct? For this port is 2, this port is 3, and this port is 4. Here we have hub. Hub is what? Single collision domain. So this completely will be taken as 1 only. This 4 only. Okay, that's why this side we have only 1, 2, 3, and 4. Come this side. 5, 6, 7. Here it is connected here 8. But here it is connected to a switch. So again 9, 10, and 11. So 11 collision domains. Okay, 2 broadcast domain and 11 collision domain. See, where the people will go wrong when they see this hub and switch. They don't know how to calculate it. If switch and switch are directly connected, that is a one single collision domain only. Okay, so here whatever devices it is connected, it will taken as 1 by each. But whereas hub will completely taken as 1. Though there are 3 devices, I'm not going to connect it as each because it has single collision domain. Okay. Note down this topology in your note copy and then write down broadcast domain is 1, 2 and collision like this you can write down 1, 2, 5 minutes. 1, 2, 3, 4. So here you can write down 1, 2, 3, 4, 5, 6, 7. So 7 plus 4 is 11, 11 CD and 2 BD.
Again, I am confused. I don't understand this broadcast language.
Well, what is the problem here? Why you are not understanding? What you are not able to understand?
What is mean by actually broadcast and collision?
What is broadcast? What is yesterday's class? What is broadcast communication?
To all. data.
One to all.
Yes.
That is broadcast communication. What is broadcast domain means? Your router is not going to send the data to who's, if he knows Dinesh, then only he will send. Okay. But switch, what does it do? He will ask who is Dinesh to everyone. Router, if he knows Dinesh, he will ask who is Dinesh. I mean, this is Dinesh. Otherwise, he's not going to ask only. He'll just simply drop it. That is the difference. See, I will upload the recording, today's recording again. Tomorrow by end of the class, you will get it. And you watch the videos 1 time, 2 time. Still you're not able to understand, come to me, I'll solve. Except, I think Raghavendra, right?
Yes, sir.
Yeah, except him, is there anyone who haven't joined WhatsApp group? Raghavendra, I've sent you a link, you can join in your
Okay,
chat.
sir. Fine.
Others. Okay, everybody joined, right? Okay. All right. Written this. Note it down, everyone. Understood? What about Srihari? Understood?
Sir, what happens if a router is in between hub and switch?
We are not going to place router in between hub and switch.
It's not hub.
We are not going to play. If it's a router there, then that link will become broadcast domain.
It will become
See.
broadcast domain and there will be 3 broadcast domains.
Correct. We are not going to place the router down. Router is used to send data from one network to another network. So where your router will be when you're going out to a different network, there only will have. Inside a network, we will not have multiple routers. Only one router will be there.
No, for such broadcast domain, you have to just see how many connections are there with the router only.
Correct. Router is a broadcast domain.
How many switches connected to router are?
Everything will be taken as one
Broadcast
single broadcast domain only. See, if there is a router, under this router, there are 10 switches. Then all the 10 switches
broadcast
are
domain.
single broadcast domain. But how many collision domain? 10 collision domain. Okay. Online guys, written.
Sir. Yes, sir.
Yes, sir. Yes, sir.
All right. So that's it, I think, for yeah. Today, this is your network component. So today, what we have learned, what is LAN MAN CAN network? Correct. After that, we have seen what is network, what is topology, and mesh topology, star topology. We have seen, and then difference between hub, switch, and a router. So now that if they ask you what is a router, you will have some idea what is router. What is a switch, you will have idea. Okay. In upcoming classes, we will learn in detail. Okay. So that's it for today's class. So we have seen what is hub switch router, broadcast domain, collision domain, and we have discussed these cables. Okay. So we'll wind up here today, and tomorrow we'll learn IP addresses. Okay. All right. Thank
Okay,
you.
thank you.
Thank you. You can leave the meeting.